Thank you for coming and attending my session. It's a pleasure to be here in Denver. I've been in the last Linux Foundation event, was in Europe, in Vienna last year. It was good. And before getting into the weed, a couple of questions for you. Has anybody of you played a little bit with AI agents in the... Oh, a lot. How many of you have played with multiple AI agents in a single environment? Okay, few of you, good. So, just a few words about me for people who don't know who I am. I'm currently involved in multiple organizations as AI project manager and head of AI, especially in customer service and supply chain. I'm also helping foundations and nonprofits. And the reason I'm here today is because of the Open Voiceinteroperability team. That's part of the Linux Foundation AI and Data. I will explain a little bit more in the next slide. What I'm gonna describe you today is a little bit, well, first of all, we will have a little bit of introduction. Then I will introduce the new open floor Agentic AI framework we just released the past month. Even if we are working on this interoperability standard, we've been working in this in the last 3 years, the latest 3 years. And then I will share with you a bit about the Beacon Forge framework. You can use totally open, of course, for free. And the second part of the presentation will be about some use cases and some side effects, beneficial, I would say, in using interoperability standards in AI agents like ours to build trust in AI. In particular, we will see how it can improve, it can help in hallucination mitigation. And then how to get involved in the projects for people who are interested in. And of course, at the end of my presentation, I'm open to any questions. I will do my best to answer you, okay? A bit of history about the project. The idea started actually from some smart guys at MIT in 2020, before 2020, actually. And then in 2020, the Open Voice Network team gathered together and become part of the Linux Foundation. And in 2023, the Open Voiceinteroperability team, together with the Trustmark team, which is focused on trust, became part of the Linux Foundation AI and Data team. And recently, we released the Open Floor version 1.0 multi-agent framework I'm talking about. Well, first of all, about this specification, I told you we've been working on this for the latest 3 years, actually. The previous name was OVON, Open Voice Network Interoperable Specifications, because it was mainly about voice interoperability with AI agents, but now it's quite independent and it can work independently from the channel. That's the reason we call that right now Open Floor. But you can find more about the specification on GitHub. You can also download this archive paper we published more or less 1 year ago. There are many papers actually published. This is one of them, and in the reference you will find a lot about the specification. There is another one which is a little bit more ahead in terms of multi-party conversation, but this is good as far as you want to have a look at the specification. This is a list of some of the current contributors. We are based mainly in United States and Europe, but of course we are open to any further contributions. If you're interested, we gather once a week. I will tell you more about this Right now, I just want to thank very much all the current contributors because everything is voluntary based. Why we thought that we needed a standard specification to have different AI technologies to interact with each other? Well, mainly because, as you may know, there are tons of chatbot, voice bot. Nowadays, we call them AI agents around the world. And they are built with different technologies. They are provided by different vendors. And usually, they don't talk each other. They are very good and orchestrate multiple agents inside their ecosystem. But it's difficult whenever I want to use an agent or a multiple agents built with a technology A, and I want to escalate the user request to some other agents built with technology B to be able to do that. And there is need for that because mainly each agent normally is specialized on a specific scope on one side. On the other side, there is also security and privacy issue. So maybe the front-end agent cannot provide the user all the information, but it needs to rely to some other specific agents with the proper permission to do that. So we came out with this specification. Now it's called OpenFloor. Basically, is a set of JSON messages. We call that universal OpenFloor API. And it's particular because inside the JSON, you can use a natural language to interact between agents. So it's a mix of natural language and JSON API that you can use. This is an example that we actually provided. One use case that we have, it's the government of Estonia. They are quite advanced in terms of digitalization. So already a couple of years ago, they deployed our specifications for Estonian citizens. So there was a front-end agent, very general purpose, front-end chatbot, let me say, that was going to provide general information, okay, general purpose information, and then some back-end specialized agents. Maybe one for healthcare, another one for information about visa. This one I'm going to share with you here. It's called the Smart Library. It's an agent specialized in providing information about books and authors, in this case, Estonian books and authors. So with a set of JSON messages aligned with our specifications, those two agents could interact each other, okay? And at the end of the day, the Smart Library agents are going to providing specific information about books to the Estonian citizen in this case. This is just an example, of course. Recently, we came out with a playground, a kind of sandbox that you can download. You can for free access to this on GitHub. It's called Beacon Forge. It's a Python framework. I would say nothing fancy, but is very simple to use. You can install that and just launch that on your machine. It's very easy. And what you get when you install that, it's a ready-to-use environment to play with our specification, okay? So you will find inside, there are two or three mainly Python scripts. You can look around. There is a dispatcher, a dispatcher agent that is going to interpret, is going to understand the intent and the concept about the user request. And it's going to route the messages to the proper agent. You will find three available agents: Pete, general purpose agent. Then there is Athena, the Smart Library agent I was mentioning before. And there is Zeus, that's an agent that is going to call external API, maybe also via MCP if you want, to provide you real-time weather information, okay? So whenever you install Beacon Forge, you can play with this architecture. Of course, you are free to customize those agents. You are free to add more agents according to your needs. This is an example of API. As you can see, is a JSON structure. In yellow, you can find, in this case, an example of what we call the utterance. And in natural language, this agent, let me say the agent A, is going to ask to agent B, tell me about the book, The Heart of Darkness, please, okay? So he's asking about a specific book. And the agent B, that's specialized about books, is going to answer. It's not important, the answer now, but the yellow about the book, but the structure, okay, is going to use a similar structure with an utterance response. It's very important to say that you can deploy each agent with the technology that you want, okay? You can use the LLM, LMM, LAM, how do you want to call nowadays, okay? You can have agents to interact with MCP, with other orchestration protocols, with other agentic framework, okay? We don't mind about that. The important thing is to use this JSON structure to have different agent infrastructure to interact each others. A second example we thought about already a couple of years ago was, okay, I'm an agent, I want to publish my capabilities to the world, and I can do that by publishing a manifest about my capabilities, okay? According to a very simple architecture JSON schema. And this is an example of get manifest request when agent A is asking to agent B, hey, give me your manifest. Tell me what you are going to do, what you are capable to do. And the agent, in this case, my smart library agent, is going to reply like this, okay? And he is telling something like, provide information about books. Author is telling about what kind of books he specializes in, the languages supported, and so on and so forth. There are other API to discover agents, and so on and so forth. I will share with you also, of course, the GitHub where you find all the open floor specification updated. So I want to now move to the second part of the presentation where I want to talk a little bit about a side effect. Excuse me. I would say a positive side effect that we experimented in multi-agents environment. And this is about hallucination. Just to be everybody on the same line, what we mean by hallucination is when an AI agent is going to provide incorrect information, but with a confident tone. And so we were wondering, more or less last year, it happened, well, maybe if we use multiple agents, we can somewhat mitigate the hallucination. By the way, hallucination cannot be totally mitigated. Hallucination will always be present. There are many papers talking about this, okay? I don't want to get into it, but you will find many papers, and many important papers that proved that hallucination cannot be zero, never. But they can be mitigated. And the other question was, maybe by using our framework, our NLP-based framework, our agentic multi-agent framework, we could also mitigate some hallucination. So what we did was, we did an experiment. So we injected more than 300 prompts to try to induce hallucination. I will explain you more about that, but yet more than 300 prompts to create, let me say, hallucinations. And there was a first level agent, a front-end agent that was doing nothing special, just trying to answer the user request without so many filters. The second level agent, the reviewer, instead, the purpose of it was to detect the hallucinations and explain the reason behind potential hallucinations to the third level agents by sending our specifications messages to the third level agents, okay? And the third level agents try to still mitigate further the hallucinations. So basically 3 agents orchestrated each others to try to mitigate the hallucinations, and from the second and third level agents using our specific standards to send messages. And then there was a fourth agent. We called him evaluator agent, and the purpose of it was to evaluate some kind of KPI. We call that total hallucination score at each step, okay? So what's the hallucination score about the response provided by the first agent? What's the hallucination score after the second agent response and after the third agent response? How we could induce hallucination? There are many techniques to do that. One example is to combine factual with fictions to deceive in some way the LLM. You can see an example here, the answer provided by the first agent, and in orange in the bottom you will find an example where the second agent detected some hallucination and provided the reason behind potential hallucinations to the third level agent by using some of the fields inside our JSON structure of the specifications, of the open floor specifications. So this is the example where the second agent is gonna explain or try to explain reason behind potential hallucinations in yellow here. In particular, we are using a private utterance to do this. We will find more about that in the specifications, of course. We didn't find so many KPI in the literature. There is a lot about hallucinations, but not much about KPI, how to measure the hallucinations, actually. So we came out with some new KPI, in particular the 4 KPI that you can see here. The factual claim density, grounding, disclaimer, and so on and so forth, and with a formula. Of course, in the paper you will find more about that. What's important to understand here is that the lower this total hallucination score, the higher the hallucination mitigation, so the better the performance. So we wanted this score to be lower, as much lower as possible. In this chart, you can see on the x-axis the 300 prompt, on the y-axis the level of hallucination score. And again, the lower the score is, the better the performance. In blue, you will find the total hallucination score level of the first agent, in orange, the second, and in green, the third agent. Yet you can see average is much lower than the third, much more lower. So it actually worked. Of course, with some limits I'm going to explain now, but basically we experimented a significant amount of hallucination mitigation. In particular, in this experiment, we reached something like 28-time decrease in hallucination, or in other terms, more than 90% reduction in hallucination score. There are some limits, of course, in our research. First of all, for practical reason, we used our open floor specification, and each of the 4 agents used at the time a proprietary GPT-based LLM. We are working now to use open weight LLM and see the performance. There was no human feedback in the loop. We think that if we were able to add some human in the loop, the performance would increase. And also there was only a single shot, let me say, for prompt injection, but usually it would be nice to have the user to try to deceive the agents by trying multiple times. And that's not easy to simulate, but we are thinking about that. Of course, everything is public. You can download the paper here. It's on archive. I'd like to thank also Deborah Dahl, our project leader, coordinator of the Voiceinteroperability. And she helped me a lot in this research as well. We published a second paper, which I'm not talking about today, maybe at the next Open Source Summit, I don't know. It's about another, well, actually, it's the first risk also that the OWASP organization is publishing right now, and it's about the prompt injection problem. Okay, so we used a similar architecture with multiple agents to see, okay, can we reduce the prompt injection problem with Agentic AI by using our framework, and we got some result. Good. Before coming to the end, the most important part, contributions are welcome. If you are interested to work with us, we normally meet once a week. Discussions are open. Sometimes we discuss, sometimes we argue, but at the end we were able to come up with quite a good specification that is going to use a really independent framework to have multiple AI agents architecture talking each other. You can access actually the specifications. I partially showed you some JSON in the past slides, but you will find the full specification in this GitHub. I will be here around. I'm playing some demo as well on the open floor specifications in the booth, in the LFAI and Data booth, in half an hour, from 3:30 to 4:30 p.m. today, and on Wednesday at 1:30 p.m. until 2:30 p.m. I'd like to thank you very much. Before the end, since we still have time, I can show you a little bit of how the JSON API works. So this is an example of API, the JSON structure here. I'm trying to... Okay. Better now? And yeah, you can see here an example of open floor, in this case, get manifest. I'm query this. This is on Python Anywhere hosted machine. You can host where you want. So if I'm sending this request to my machine, in this case, to the Athena agent, I'm going to get this answer, okay? So let me see here, okay, cradle of knowledge, capabilities, books, author, and so on. I can ask this to Athena, so the specific book I want to know, and it's going to send a query, and hopefully I'm going to get an answer. Now the LLM is trying to reasoning, and it gets back me to with this answer. I can ask, for example, to Zeus about the weather, Let me see, not the invite, I want the utterance. Okay, so what's the weather like? You see here. So this is in London. I don't want the weather in London. I want the weather in Denver. Okay, you can see here. It called the external API, and it provided some weather information. Okay. So whenever you install Beacon Forge, you can play with the API. You can actually customize it according to your needs. Well, thank you very much for your attention. Any questions? Anything you want to know? Yeah, just let me give you a microphone. The gentleman there is going to give you a microphone over there, so everybody can hear.
Please just benefit. Yeah, sure. Thank you. Hello, can you hear me?
Yeah.
Okay. It could be quite simple. So, what exactly does multi-agent helps in? Like, do you know the reason it happened? Like, does the model makes any difference, or does the score change when you just change the order of the agent? Like the agent 1 becomes the 3 and the 3 becomes 2. Like have you guys done any such exercise where you shift the order of the agents?
But are you talking about the hallucination
yes, the hallucination
experiment?
Score, yeah.
So what the question is about the specific agent?
Yeah, so what I'm saying is if an agent you have tagged as 1, agent 2, and agent 3, right?
Yeah.
You have 3. So let's say you change the order of those agents, like the response goes to 2 first rather than 1, and then from 1 to 3. Does the score change? Have you done any such kind of patterns?
We didn't try to change the order, but I don't think in our experiment would change that much because all the agents were, well, no, the first agent used a simpler LLM, okay, to simulate a simpler agent that is not very strong in tackle the hallucination, okay? So I'm expecting that in that case, if I change the order, maybe I will have a better mitigation already between the first and the second agent than like here from the second and third agent, okay?
Okay.
That's what I can expect, but it must be tried, of course.
Okay, thank you.
You're welcome. Anybody else? Oh, yeah. Thank you.
Hi, so I think this was also in the same implementation. You mentioned that you were switching from the GPT models to the open weights models, and I was just wondering if you could give some context on why that? Is it having to do with like cost, quality, latency? What's driving the switch?
Yeah, of course. Well, in our case, it's just to understand if the hallucination mitigation score changes in some way. Generally speaking, I would say I would like to use the open weight model for multiple benefits, like I can deploy them on my GPU, maybe for privacy reason, I want to do that. I'm based in Europe, so we are very much, we pay very much attention, you know, in GDPR, privacy, and so on. So I personally like very much the possibility to use, when I can, the open weight model for that. There is also the flexibility to do a fine-tuning of the model for my purpose, my specific purpose. That's the second reason I would do that. And yeah, those are the two main reasons. Then, of course, we can have a discussion about what's a real open source AI model and what's not. You know about the discussion ongoing, but that's another story, of course. Yeah. Thank you. Anybody else? Any other questions? Okay, I thank you very much, and I'm looking forward to meeting with you maybe at the booth if you have any chance. Thank you so much.